come from Montpellier, but we've got a collaboration with David DeVos from Lille. It's a reason why. So, thanks the organizing committee to give me the opportunity to present our work. I will focus on the methodology much more than on result, because it's really the beginning of our study. So my talk will be about the evaluation of the potential of isoprostanoid to predict ALS progression. And so we know that under oxidative stress, the reactive oxygen species product in excess will interact with macromolecules of the organism, such as lipids, nucleic acid, or proteins, leading to the occurrence of some injuries and at least of the development of some pathology, such as neurodegenerative disease, cardiovascular disease, or some cancers. So how to evaluate this oxidative stress? We can try by evaluate it with direct method, but due to the short half-life of ROS, it's a bit difficult, and it's a reason why often we prefer to use some indirect method, and for instance to evaluate the level of compound coming from the oxidation of such macromolecules. And if we focus on polyunsaturated fatty acid, the radical attack of this highly reactive compound lead to the formation of a wide diversity of metabolites that we call isoprostanoid. And for example, linolenic acid give access to phytoprostan, arachidonic acid give access to isoprostan from the SERI2, EPA to the formation of isoprostan from the SERI3, and DHA to the formation of neuroprostan. So why these compounds are interesting? Because they are oxidative stress biomarker, and so in this case, perhaps we can consider that they could be a good tools to perform the diagnosis of disease related to oxidative stress. And in fact, we've got the first publication from the Mitsumoto team who show effectively a positive correlation with sporadic ELS and the amount of 15F2T isop, a compound coming from the oxidation of arachidonic acid. This compound is also a gold standard of systemic oxidation. But measurement of a single compound may not be enough, and it's the reason why we are interested in the targeted lipidomic focus on isoprostanoid. And we expect here to find some alternative biomarkers of prognosis helping stratification for clinical trials and or diagnostic biomarkers for drug acting on lipid peroxidation. So from a methodological point of view, the analytical workflow that we applied consists on two steps. The first one is a sample preparation in order to limit a matrix effect and to enhance the sensitivity of the quantification. So we perform first an alkaline hydrolysis, and then we purify the extract on solid phase extraction. Then we perform an LC-MS analysis, which all parameters were optimized. You've got some information about the micro-LC chromatography. And here the condition of mass spectrometry, we work on SciXQ-trap instrument. We work with an electrospray ionization in negative mode, and we follow a multiple reaction monitoring. That means that we're following the couple form with the precursor ion and the daughter ion. So we realize there really some targeted lipidomic, and we are able to identify compounds thanks to the retention time and also thanks to the two transitions, the first one for the quantification and the second one for the specification, and related to calibration curve that we draw. We are able to quantify the compound and all the compound present in the method. And actually, our methodology consists on 50 compounds analyzed in less than 16 minutes. And so now, to achieve our goal and to answer the question, we have designed the following experimental plan. We are working with a plasmatic sample coming from Pôle biobank, and we have 16 healthy individual plasma that constitutes the control group. And we also got plasma from 149 selected patients, and we've got 3 sampling times. And so we analyze this sample just at the beginning, as I previously say, because at that time, we have analyzed 21 samples from the control group and 126 samples from the ALS group. We made a random sampling, and so we've got only a complete data set of 15 patients. So the inclusion time 0, 3, and 6. It's also a partial view of the results, because at the moment we only perform an automatic integration, and this automatic integration allows the following on only 3 main compounds. So we've got all the other compounds to analyze manually, to be sure to check and to reprocess and to be sure of our results. And I show you here an example of a chromatogram, and you can see here an interfering peaks. And in this condition, it's better to perform a manual integration. So this is the reason why we've got a few data for the moment. So the preliminary data we've got, focusing on 3 main compounds, the 9L1T phytopy coming from the oxidation of HeLa, 5F2T isopy from arachidonic acid, and 4F4T neuropy from DHA. At the first view, there is no discrepancy between the control and the ALS group, whatever the metabolite studied. This is in part due to an excessive inter-individual variability. We can just observe some slight trends with a very low increase here in amount of isopy derivative and neuropy derivatives. And if we look at the details, when we analyze the 3 sampling times, conclusions are less obvious. With phytoprostan, we observe an increase in metabolite content in patients over time, whereas for the other 2 metabolites, we note a point of inflection at the inclusion time 3. And here, finally, you've got a figure who summarizes the highly disparate profile observed for the 15 patients at the 3 sampling time, the amount of metabolites can increase or decrease or stay equal. And for one individual, compounds could follow the same trend. It's a case here, or some opposite trend. It's a case here, for instance. So far, no conclusion yet. So now we need to complete the analysis of the remaining sample. We have to do the manual analysis of all the metabolites. And we have also to take into account the batch effect to normalize data. And then we plan to combine data with ALS, FRS, air rate data. I forgot the hair. With HNE and HHE value in order to have a better prediction and score of patient, and of course to try to evaluate the relevance of the model. So thanks you for your attention, and thanks for RS SLR for its financial support.
Thank you. We have time for probably only one question.
Hi, so I had a question about the potential batch effect that you actually mentioned at the end. So basically, since you cannot do everything the same day, because you said you have a high heterogeneity, but do you see that this heterogeneity is basically less strong when you do the samples the same day? So is it really because the patients or the controller have a high individual difference? Or if you would run again the same patient and another day, you would see that it's different, and that's the real batch effect?
We notice a batch effect, yeah, and it's important to normalize it. But to analyze this type of sample, to prepare the sample and to work with sample, we need a lot of time. Average, we are able in 1 or 2 days to analyze less than 20 blood sample. So it's important to try to normalize thanks to the batch. But I guess that we will get also some information about the sex, the age of the patient, and so on. It will be probably more relevant, but for the moment, we work only in a blind condition. We only know that if it's a healthy individual or a patient suffering from ALS. So it's really the beginning, and we hope that we will be able to find some correlation and to confirm the data obtained by Mitsubishi teams. Because at the moment we haven't measured the amount of 15F2T isop, the compound evaluated in the publication.